on your particle motion corrective.
I know, I thought I did pretty good, but third time was not the charm.
Oh no, I feel the same way. Particle motion's super hard.
It is.
We need some help.
I know.
Hello, I'm Laggy.
And I'm Morin.
And we're here for your nightly news.
It's 6:03 p.m. on an 82-degree sunny day.
We just got news that all over the country, especially in Northern California, specifically 30 minutes outside from Sacramento at Rockland, California, Rockland High School, Mrs. McCullough's Period 1 class.
They are failing particle motion. We're here with the math experts, Gertrude and Pearl from University of Kansas. They're gonna help you out. Oh, hello, we'd love to help you.
Hi, I'm Pearl,
And I'm Gertrude.
and we're going to help you with particle motion. So, we were first given an equation for position, and we're setting our little integration limit. So, basically, you're going to be using three equations: your position, your velocity, and your acceleration. And how you go from one to the other is you derive.
So for this example, we have position equals 1/3 t cubed minus 3t squared plus 8t. When you derive that, you get the velocity equation, which equals t squared minus 6t plus 8. When you derive this equation, you get the acceleration, which is 2t minus 6. These all help you find speed, direction, distance, displacement, and location. First thing we're going to go over with you lovely students is what is the position at t equals 3? Pearl, what do we do?
Okay, since it's about position, use the position equation that we have when t equals 3. So you just plug in 3 for position. So you plug it in for everywhere there's t, you solve it, and the position at 3 is 6. Another main topic we have is when is the particle at rest? Gertrude?
Okay, in order to find when the particle is at rest, we set the velocity function t squared minus 6t plus 8 equal to 0. And when we do that, we get t equals 2 and t equals 4. The question you might be asked on the AP exam is when is acceleration 0? Pearl, tell them all about it.
Okay, so we're going to be using our acceleration function, which is what we found out by deriving from your velocity equation, and you set it equal to 0 because that's what it's asking. And then you solve it and you get t equals 3.
Trickier question you could be asked on the AP test is to find the displacement or total distance of your equation. For our example, it is asking the distance and displacement from 0 to 6. Pearl, take it away.
Okay, so for displacement is the area under the graph, positive and negative combined. So for that one, you're going to take the integral from 0 to 6 and you're going to take your velocity equation, and for this one you can plug it into your calculator, so it's easy to solve. But for when you find total distance is going to be the amount traveled. So it's like the miles you go in your car, right? And so it's going to be the absolute value of the top and the absolute value of the bottom, which is the negative. So turn positive. So that's why we have absolute value bars on our velocity equation from 0 to 6. Another main question that will be asked is when is the particle moving to the left or to the right?
So for this question, you have to start by finding your VT at 0. So for this, you have to use the t equals 2 and t equals 4 answer that we got before earlier. So when you're solving for this, you put 2 and 4 on a number line, and Pearl and I substituted in numbers like -1, 3, and 5, which are numbers along the number line in between or beyond on this number line. For these numbers, when they were substituted in, we got a positive number here, a negative number here, and a positive number here. This is what we use to solve if the particle is going left or right. We can see that the particle is moving left from 2 to 4 because it is negative. We can see that the particle is moving right from 0 to 2 because it's positive, and from 4 to 6 because it's positive again.
Being the math experts we are, Gertrude and I, Pearl, have come up with the party pleaser for your particle motion. So how it goes here. Woo! So that's where you're going to put your positive side. And positive, you like to move to the right. So you're going to move all the way over here. Then, it shifts to the negative. So you're going to move to the left. And it's negative. Try it with us.
Oh my gosh, I get it now.
This is so great. Now I can parse my particle motion.
Yes, Gertrude and Pearl were awesome.
Even I get it.